Good morning, everyone. This is Mr. Rhodes with the Unit 4 practice test. Select all the equations that have no solution, okay? So these are on the whiteboard as always, but I'm just going to go ahead and review them. If they have no solution, what we're looking for is something like what it has on the board is 4x minus 4 equals 4x plus 3. That's what's on the board for no solution, okay? And why that's no solution is because the variable terms are the same, however, the non-variable terms are different. And through actually trying to solve this, we would see that there is no possible way to actually solve a solution for x. So that's what I'm looking for in these. However, if I look at a few of these, like b and d, I can't really make that decision right now because they're not simplified. There's some simplifying that needs to be done, which means this distribution needs to happen. So I'm going to go ahead and do that for b right away. I'm going to do the pumpkin top here. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And that equals negative 2x plus 6. Okay? So I can see right away that I have exactly the same thing on both sides, which is actually the symbol for all possible solutions. So b is not going to be no solution. Remember, we are looking for any of them that are no solution. Okay, so b is not an option. Let's look at d. Okay, pumpkin top here, pumpkin top here. 4 times x is 4x. 4 times 1 is positive 4. 3 times x is x. 3 times 2 is 6. Okay? So I'm looking at here is the x terms are different and the non-x terms are different, which is the sign for one possible solution. Okay? So D is not a possible answer. Okay, so now I got to look through the rest. I'm looking for x terms that are the same and non-x terms that are different. Okay, so here I have x, 1x on both sides, so those are the same. I have 6 and 5 for the non-x's, those are different, so A will be no solution. If I look at C, I have different x terms and different non-x, which is one solution, so C is not an option. For E, I have negative 3x. Remember that minus is treated as a negative in this algebraic math, and this is negative 3x, so my x's are the same, and my non-x's, 5 versus 4, are different. So that is no solution. Okay? Number 2, what is the solution to 3x plus 30 plus x equals 10 plus 2x plus 5x plus 2? Now, since this is multiple choice, you could go ahead and take all of these numbers, put them into the x position one at a time, and see if it pans out. Meaning that if it satisfies the equation, you get an even the same amount on the left of the equal sign and the right of the equal sign. So you could do that with all 4 if you want. But we've learned how to actually solve these, so let's solve it. What I'm seeing first is there's multiple x terms on both sides, okay? So speaking of one side at a time, I should be able to take these and combine them. 3x plus 1 more x is 4x plus 30. On this side, I have 2x plus 5x is going to be 7x. And all the other numbers that haven't been used fall down in place. Okay? Now I actually have some non-x terms on this side. The 2 and the 10 need to go together. And do pay attention, I'm reading this as 10 plus 2. I have to use the symbol that's always to the left of a number. Okay? So 10 plus 2 is 12 plus 7x. And I always, every move I make, I rewrite the entire equation. I drop down whatever hasn't been used yet, okay? Now, like I've said many times lately, I'm down at the bottom of the wall looking for x equals what? Okay, so I don't want x's on the right and I don't want non-x's on the left. So that kind of guides where I want to cancel things out. So I'm going to cancel this 7x. Okay, like to box that and slash it. Minus 7x on this side is 3x plus 30 equals 12. Okay, and now the non-x's I don't want on the left, so I'm going to subtract 30, subtract 30. So here's what's up. I'm going to go kind of on the side because teaching this to our 7th grade right now, and we need to remember this too. We're starting at 12. We're going this way 30. And that means to get to 0, I am spending 12 out of that 30 units. So how far into the negatives am I going to go? And that is going to be 18. Okay, because the 18 distance to 0 and 12 distance to 0 add up to the 30. Okay, so I'm going to get negative 18 here. And actually rewinding back, if you guys didn't already catch this as I went through the work, 4 minus 7 is not positive 3, that's negative 3. Okay, and those negatives are so important because if I didn't have negative and negative, I would get a different positive answer. So I gotta rewrite here just because it's getting messy. So I'm gonna go over here. What I do have right now is negative 3x equals negative 18. Okay, that's where I'm at in my wall. Okay, so my last step is to divide by negative 3 and divide by negative 3 on both sides so that x equals 6. Now, if I want to, and you guys should if you have the time on the test, you have to put 6 into the position of every x in this and test it and see that it works. And if 6 doesn't work, then it's not the correct answer. Okay, but I am not going to do that because I have the answer key in front of me and I know that 6 is the correct answer, but you guys should be able to. I'm saving time. Number 3. Which of the systems of equations has a solution of negative 2 for x and 6 for y? Now, before you go ahead and start solving all of these using the long method we've learned, you know, there's multiple steps in solving an x and y for these. Remember way back, anytime we are actually given an x and a y, and this goes back to any of the equation tests we've had in this school year, you should know that we can substitute these numbers into any x position and any y position and see if it works. If we understand systems of equations, the point that we solve should satisfy both equations. Okay, it works for both equations. At that point, would be on line for both of them. So what I have to do is I have to go through here and I'm going to rewrite all of these with 6 for every y and negative 2 for every x. So this is going to be 6 equals 2 times negative 2 plus 10. This is 6 equals 3 times negative 2 minus 6. Okay, and the second these numbers don't work for just one of these equations, I'm done. I don't have to keep testing that system. Okay, so I look here, this is going to be 2 times negative 2 is negative 4. Negative 4 plus 10 is 6, so it works for that one. But in this one, 3 times negative 2 is negative 6 minus another 6 is negative 12, not 6. Okay, so that doesn't work. Okay, here, 6 minus 2 times negative 2 equals 2. 6 plus 2 times negative 2 equals 10. Okay, so negative 2 times negative 2 is positive 4. So that'd be 6 plus 4 equals 10. not 2. That one's already done. Okay? Remember that the multiplication has to happen first. That's PEMDAS again, order of operations. Parenthesis, exponent, multiply, divide, add, subtract. All right, rewriting here, -2 minus 6 equals 9. 6 equals -2 plus 9. Okay, and right away, -2 plus 9 is not 6. So that one stands out to me. Okay, so at this point I should be able to say it must be this, but I want to prove it. Okay, so -2 plus 2, 6 equals 10, and -4 times -2 minus 6 equals 2. Okay, so 2 times 6 is 12. -2 plus 12, remember that's left of 0, moving right over 0, so -2 plus 12 is 10. So that works. -2 times -4 is +8. +8 minus 6 is 2. So that works. Excuse me. Okay. So D is the correct answer. Number 4, Mai solved the equation below incorrectly. Identify Mai's error and then solve the equation correctly. Okay, so we got fractions in here. So as I've said many times, guys, we need to remember fraction rules and how we do these. So it's going to take a little bit of time. But I'm going to start floating through her work, try to find the error. And once we find the error, we should be able to continue forward from there. So we're starting with 2 different pumpkin tops up here. And I want to see, so 1/3 times 1/2, would that be 1/6? Okay. Now, I know off the top of my head how fractions work, that if we multiply by a fraction, you get that fraction of the number you're multiplying by. So the fraction of. So in other words, what is 1/2 of a third? Okay, if I cut a third in half, it's a 1/6. So I know that that's correct. Okay, if I multiply the third by a half, that's 1/6. Or you guys have to do this, right? 1/3 times 1/2, right? Multiply straight across. 1 and 1 is 1. 3 and 2 is 6. Okay, we have to be able to do fraction multiplication as well. So that works. 1/3 times 9, which again, that is the fraction of 9. So what is 1/3 of 9? What goes into 9 3 times is 3. So that works. Positive and negative is negative. 1/2 times x is 1/2 x. 1/2 times 18, again, what is 1/2 of 18? It's 9. So this step passes the test. Everything there looks correct. Okay? So the thing about these is it doesn't actually show the moves they make as much as I show them and how much I've trained you guys to show them. So I have to look at their equal symbol, like their wall, although there's moves all over the place. That's the wall, okay? And I have to say what disappears. So if I see on the right side, the 1/2 x after this layer doesn't exist anymore. So she must have subtracted 1/2 x. Okay? So we got to look over here and say subtract 1/2 x. And I'm already building a little bit of suspicions here because I don't believe that 1/6 minus 1/2 is a quarter. And I'm saying that just by imagining a ruler or a tape measure. I do a lot of measurements with inches, and I don't believe that that's how that works. So I'm going to go off on the side here. I'm going to do 1/6 minus 1/2 and try to figure out what that equals. In fraction adding and subtracting, we need common denominators. Okay? So I'm going to turn my 2 into a 6 by multiplying it by 3. And I'm going to turn my 1 into a 3 by multiplying it by 3, right? So remember, that's how we can oh boy, lights out. That's how we can expand fractions or simplify them, is to multiply by the same number on top and bottom, or divide by the same number on top and bottom to simplify it. So I should have 1 minus 3 is negative 2, and then the common denominator stay the same. And now this can be simplified because 2 divided by 2 is 1, and 6 divided by 2 is 3. So, in other words, her quarter here is not correct. So that should be negative 1/3. So I'm going to jump down. I'm going to rewrite this with the correct fraction I got. Okay, and I'm just going to, right now put a big arrow here that's the error. Okay. Negative 1/3 x minus 3 equals 9. Okay. And then I have to follow through because I found the error. 1/4 is supposed to be negative 1/3, and I should be able to continue on from here. So again, I want x equals. So I'm going to take my non-x off the left. I got to start canceling out everything else I see here. So plus 3, okay, that cancels. 9 plus 3 is 12. Negative 1/3 x equals 12. So I'm going to divide by negative 1/3 because I want that to be 1x. So we divide. Okay. Now I could go over here and keep change, flip, which would be 12 over 1 for the whole number, 12 divided by 1/3. Change to multiplication and then flip to negative 3 over 1, which is going to get me negative 36 over 1, which equals negative 36. Okay. On the other hand, remember, and at least this is again something I'm telling my 7th graders a lot this year because they're seeing division and multiplication with fractions. When we divide by a fraction like 1/3, and you know that that's the same as multiplying by its reciprocal. It's flip, right? This is the flip reciprocal. So dividing by a fraction is the same as multiplying by its denominator, as long as the top is 1. Okay, so 12 times 3 is 36. So I would also know it that way. But positive times a negative is a negative. Okay. All right, here we go. This is a really important example, guys. We're solving this system of equations. We have to remember the steps, and it is to substitute, in most cases, the y. Okay, we're going to substitute a y. We're going to solve then the x, and then we're going to re-substitute the x. Okay, so I can see those steps right here. I can substitute the y because I have a y equals something, and if the y equals something, that means that this something can go right there. Okay, I'll make an arrow on top too. Can go in the position of that y. Okay, I've been saying it that way for a while now. If y equals that, then that can be y, right? If y equals that, then that can be y. Okay, so I'm going to write out this equation. The top one, 1/2 x plus 6y, right? So now instead of y, I'm substituting it with what the other y equals, which is x plus 15, and that equals 12. Okay, draw my wall, knowing that at the bottom of my wall I want x equals a number, and that's going to help guide me because I want x alone on the left side. Okay, I have a pumpkin top or dog butt here, so it's always the first thing I want to do. Anytime I see the opportunity to distribute, that is my go-to move. So 6 times x is 6x, 6 times 15. Okay, let's see, 15 doubled is 30, doubled again is 60, so that's 4, and then 60 and another 30 is 90. Okay, equals 12, and 1/2 x is still there. Okay, so want to start canceling things out, and I also have some like terms to combine. So I have a half x plus 6x, so I can make that 6.5x if I'd like. Okay, I can subtract 90 off both sides because I want this 90 to be gone. Okay, 12 minus 90, again, simple number line thinking here. Of course, I'm sure a lot of you will use a calculator, but I refuse. Okay, 12 minus 90 is our operation. We're going this far, so we're using 12 of the 90 to get to 0, and we're crossing over the rest of that. So, right, we're using 12 of the 90, which is going to take me to 78. Okay, negative 78. So ultimately, I'm going to move this over a little bit because it's kind of out of place. I have 6.5x equals negative 78. Okay, so now I have to divide by 6.5 on both sides. And again, don't panic. Yeah, we're divided by a fraction here, or of course with your calculator you could divide by 6.5. But again, I like to prove that I can do this, right? So negative 78 over 1, we're going to keep, change, flip. Okay, so instead of divide, we're going to multiply, and I am going to, I need 6.5 in the improper. So 6.5 as an improper fraction is 6 times 2 is 12, plus 1 is 13 halves. Okay, so I'm going to flip 13 halves, which is right there. Okay. So some big numbers here, but some mental math, right? If I had 70 and I doubled it, I would be to 140. So now what if I doubled 8? That'd be another 16. So 140 plus 16 is 156. I do notice I'm using the negatives here over 13. Okay. And for the sake of time here, I'm doing 156 divided by 13 on the side, and that equals 12. But don't forget the negative. Okay. So my answer for x is negative 12. Okay, I wish we were done then, but we're not, because I also need to figure out an answer for y. Y has to equal something too. Okay, so I go back up to either of my equations, probably the one that looks a little bit more simple, like y equals x plus 15. So y equals x, which is negative 12 plus 15. Okay. And then again, number line, so I'm at negative 12, zeros here. I'm going to go 15 in this direction. All right, so I use 12 of the 15 to get there. So there's going to be 3 left over that passes it. So y equals, 3. And that whole answer could and should be written like this. It's the x and y coordinate, negative 12, 3. Number 6, Lynn and Han's families provide money for their school lunch accounts. Han starts with 100 in his account. He spends 15 each week on lunches. Okay, now right away I'm thinking equation, right? We have to always remember y equals mx plus b, especially when I hear a starting number. Okay, which can be our y-intercept, right? And then some sort of rate or pace is going to be our m, which is like a slope on the graph, right? So if I hear those two things in the story, those numbers go in those positions. So Han starts with 100 in his account, starting number. Okay, he spends $15 each week on lunches. There's a rate, $15 per week. So his equation, we'll go over on this side, Han's equation should be y equals 15x plus 100. Okay. Lynn starts with 25 in her account and does not spend any of it. Oh, I'm sorry. He spends $15 each week. Spending is minus money. So I got to come back here. This 15 needs to be negative. He's taking 15 away every week. X being weeks. Okay. Y being dollars. Okay. Lynn starts with $25 in her account. There's a starting number, literally says start, and does not spend any of it. Her family adds. That's going to be plus $10 each week. So her equation is going to be Y equals 10X, adding $10 per week. Remember, the X is number of weeks, starting with $25. Okay, so I got the equations for these two. They're pretty easy equations because it fixed a standard structure we've been dealing with for a couple of months now. And then it says at the end of 4 weeks, who has more money in their account? Okay, so remember as I built those equations, X is for weeks and Y is for how much money they will have. So I can take 4 weeks and plug it into the X position for both of these and see what's going on. So for Han, he's going to have Y amount of money after taking away $15 for 4 weeks after starting with $100. Okay, so 4 15s, it's 15, 30, 30 doubled is 60, so minus $60 after starting with $100, and he ends up with $40 after 4 weeks. I mean, that's Y, sorry. Y equals $40 after 4 weeks. Okay. Lynn is going to be Y equals plus $10 for 4 weeks after starting with $25. Okay. $10 for 4 weeks is $40 plus the $25 she started with. Lynn's going to have $65. Okay, so who has more money in their account after 4 weeks? It is going to be Lynn. Now, side note, you guys could go ahead and make a table if you wanted to, right? I could have Han and Lynn, and I could make a table for a number of weeks, right? 1 week, 2 weeks, 3 weeks, 4 weeks. And I could go with that, right? And see what happens. Oops, sorry. I don't know why I wrote 3 twice. Okay. The trick with this, though, and the issue with the table is everybody wonders what goes in for 1 week. Is that the number they start with, or is that after some money comes off after 1 week? And if we struggle with which one of those versions is right, then the table becomes messy. Like, it's hard for us to know what's going to happen week 1. So the truth is, the starting number is supposed to represent like week 0. It's like before any weeks go by, Han has 100 and Lynn has 25. So after 1 week goes by, then it's with the money being added on or subtracted. So for Han, that would be $15 less, which would be 85 there. And for Lynn, that would be $10 more, which would be 35 there. Hans keeps going down by 15 each time. Okay, and Lynn's keeps going up by 10 each time. Okay, but again, it's that starting week that is the issue there. Is that the starting number, or is that after 1 week of money comes off or added? That is after 1 week. So that's kind of the pickle there. So be careful when you make tables. All right, after how many weeks will Han and Lynn have the same amount of money in their lunch accounts? So that's, again, the system of equations. That is why we started doing systems in the first place, is when we were wondering, when will I have two equations that will actually be equal to each other. That's what systems are. When will they be the same? Going all the way back to the tank activities, one tank's filling, one tank's emptying. The elevator activity, one's going up, one's going down. When will they be exactly the same? Okay, that's the case with this too. Lynn's account is going up, Han's account is going down. When are they going to be the same? So I'm going to take these two equations, even like looking at them right here. I'm going to take one person's Y amount and put it into the other person's Y. Okay? So that is going to turn out to be, I'm going to write it right here so we can maybe see it, negative 15x plus 100 is equal to 10x plus 25. Okay? Make my wall knowing that I want x equals what? Okay, remember x again is the number of weeks. It's asking us how many weeks. That is x. Okay? So since I want x's on the left and a number on the right, I'm going to get rid of the number on the left without an x. Minus 100, minus 100. That one cancels. This one turns out to be negative 75. 10x minus 75 on that side. And my negative 15x falls down into place. Okay, now I don't want any x's on the right side, so I'm going to cancel that out with subtraction. Remember, negatives minus more is more negatives, so that's negative 25x equals negative 75. Okay? And let's see. Divide by negative 25, divide by negative 25. So remember, negative divided by a negative is a positive. 25 goes into 25 goes into 75 3 times. So that is 3 weeks. Now again, you may have saw that if you did a table up here as well. Okay? But then you have to really explain your work down here, right? This is a test where I'm expecting to see a lot of work or explanation so that we can get points for those things. Number 7, and this is again kind of the big complicated one. You have to come up with some a little bit more random equations for this one and fill out a table. So there are 50 athletes signed up for a neighborhood basketball competition. Players can select to play either a 6-player game, 3-on-3, or a 2-player game, which is 1-on-1. All 50 athletes sign up for only one kind of game. Complete the table to show different combinations of games that could be played. Okay, so we have to look here, guys. We consistently have to equal 50 players. Okay, but remember these numbers in here are not the number of players. These are the number of games. So if I have that many number of games, I have to figure out how many players it would take for that game, right? So if there's one game with 2 players, that is 2 players. Okay, which means I have to use 48 players over here. I need 48 players. So how many 6-person games would that be? So 48 divided by 6 is 8 games. Okay? So again, this has to equal 50 players. And I'm, again, putting players in parentheses here. The number of games is not in parentheses. So if it's one game with 6 players, that's 6 players. So if 6 players are used there, I only have 44 players here. So 2 people per game, 44 people would have to be cut in half. That would be 22 games. If I have 4 games here with 2 people in each, that is 8 people. So I would 8 out of the 50 players I need. So I have 42 left over here. Okay. So I should have 7 games there. Okay. 7 games of 6 people is 42 people. 4 games of 6 people is 24 people. So out of the 50 people or players, how many do I have left? It's going to be 26 people, which 26 people with 2-player games, that's 13 games. Okay. So as I fill that out, I can see, hopefully maybe some patterns going on here and also some math. If I have to equal the number of players, I need the number of games, times the people per game, right? Plus the number of these games times the people per game to equal 50 players. So I'm already starting to notice an equation here. Okay, so I'm going to write that down actually. I'm going to make, let's see. I'm going to make the 6-player games my X and my 2-player games the Y. And that actually, we need 2 variables in order to make an equation, right? So I'm going to say the 6-player games, which is X, right, times 6 people for those games, okay, plus my 2-player games, which is Y, times 2 people for each, is going to equal 50. Now I'm just writing that down because if I see any equations as I do this type of work, if I notice any equations, I want to write them down, right? And I notice that equation because that's exactly the math I did up here. That's exactly the math I did up here. If there was a 4 6-person games, I had to multiply by 6, right? If there's 13 2-person games, I had to multiply by 2, and I had to add all of that together, 24 and 26, to equal 50 players. Okay? So now let's read B and see if this equation is going to be valuable. If the neighborhood holds 13 total games and all 50 athletes participate, how many 6-player games and how many 2-player games are held? Okay? So yes, if you wanted to, guys, you could hack out a really long table and try to figure this out. But again, this is really asking us to use a system of equations. So if I can build a second equation out of this information, then I can start to use them together. All right? So what I'm looking at here is I already used the 50 participants as a total right here. So notice this is italicized because in order to build an equation, every equation needs to total or equal something, right? So I need to figure out what math would be necessary to solve 13 total games. And so far, I have X that represents 6-person games and Y that represents 2-person games. So my number of 6-person games plus my number of 2-person games have to equal 13 total games. So there's my second equation. Okay? Now, I want to be able to substitute here, but like your worksheet the other day, I need one of my equations to be reformatted. Okay, and I'm going to do that with the easier equation here because there's just less in it, and I can really just move this X over to the right side, so I have Y equals what? Okay, I need to reformat into a Y equals what situation so that I can plug it into my other equation's Y position. Okay, so I'm going to take this, I'm going to subtract X from both sides so that Y equals 13 minus X. Remember, I cannot actually subtract. Like this is not going to turn into 12x because 13 does not have x's or does not have any variable. So I can't subtract this x from it. So I can really just set it next to it. 13 minus x. So now that Y equals 13 minus x, I can come back up here and put it into this Y position of the other equation. Okay? So I'm going to do that right over here. I'm going to do, oh man, lights out. All right, we're back. Okay, so 6x plus 2y, but again, now y is this. That's what I'm going to put there. Y is 13 minus x equals 50. So I wrote this whole equation, just putting my new value for y there, which is 13 minus x. Okay, so I can draw a wall. Okay, and now I just go to my rules of solving. I have to distribute first. There's my pumpkin top. 2 times 13 is 26. 2 times negative x is negative 2x. 6x is still there. And 50 is still there. Okay. I have some like terms. I see negative 2x and 6x. So 6 minus 2x is 4x. And 26 comes down to. So 26 plus 4x equals 50. I want x by itself in the end here, so I'm going to get rid of my 26 by subtracting. That's a cancel. 50 minus 26 is 24. 4x equals 24. Sorry, I wrote that in a bad spot. So now I'm going to divide by 4, divide by 4. So x equals 6. Okay? So right now that means, since x, again, is my 6-player games, that means that we're going to have 6 6-player games. Okay, so I'm going to write this over here. Number of 6p games, 6-player games, I'm going to have 6. But now I need to figure out then how many 2-player games. Okay, I can do that a couple of ways. I could come back to this table, right, and do it kind of like that. So if I have 6 6-player games, that is going to be 36 players. I'm sorry. If I have 6 6-person games, that's going to be 36 players, which is going to leave me with 24 players left to play 2-player games. So 24 players playing 2-player games would be 12 games. So I can solve it that way. That's just kind of like logically solving it, the same way we did that math up here in the table. Or I can take my restructured equation here, since there's a nice x on this side, and I can put my x value there, which was 6 games. Remember? X equals 6. So now I can put 6 in an x position. So, I'm going to run into an issue. Let me pause here and figure out what I did wrong. I see what I did wrong here. 36 out of 50 players is only 14 players left over, not 24. So I don't know what type of mental math I was doing there. It's only 14. So 14 players playing 2-player games would only be 7 games. Okay. So coming back here, if I have y equals 13 minus x, and x is now 6, now it makes more sense. So y equals 7. And that could also be written like this as a final answer. 6 7, or 6 6-person games, 7 2-person games. And remember, in parentheses, that's number of players, just so we're not getting confused with what those numbers mean. Okay? All right. Good luck on your test tomorrow.